Welcome back, everyone. Hope you got refreshed, got a coffee. You're good to go for our second and final session of today. I just thank everyone, the three speakers from the first session was really great. And we're going to move into this session. I want to introduce the moderator for this session. That is Monsieur Bernard Lemarié from La Poste. Bernard is head of their network optimization program. And so Bernard will moderate this next session and the Q&A at the end. But Bernard is also the opening speaker for this first session. So Bernard, I'll hand over to you.
Okay, let me quiz on. So good afternoon, everybody, or good morning. Thank you, Jan, for the opportunity to make this presentation and also to moderate the session. I will present you a subject concerning mail, and mail, as you know, for every one of you, is in a decline process. But in La Poste, we have still the idea of improving the processing of mail, and especially for the flat mail. And one of the important reasons for that is that flat mail is sometimes very close to small parcels. So when we improve this the process for this kind of mail, we also improve the process for some part of the parcel flow. So our idea on the flat mail is that just a moment. Our challenge is for mail, for flat mail, it's mail sequencing. Just to recall you that as many postal operator, we have several levels of sorting mechanization when we're on sorting center and when we sort for delivery center and for the postman who will deliver the mail. We have one sorting level which we call delivery center level. This is a minimum level of sorting we can do. We have to sort when we do this kind of sorting. People in the delivery center have to manually sort in 2 steps. The intermediate level is what we call delivery round level. And in this case, the postman receives its own mail for its round, but you have to sequence manually this mail. And the best we can do is, in terms of mechanization, is the sequenced round level. And in that case, we deliver to the postman the mail in the good sequence for this delivery round. So you have no sorting to do in this case, but you have nevertheless you have to merge this mail with other unmechanized mail which are at a low level of sorting. When we speak about different type of flow of mail flow, of course we have the standard letter, standard format letter, and for this kind of letter of mail, we sort at the sequenced level about 85–90% of the mail flow, which is very high. There is a part of this mail which can be sorted at this level because it is difficult to read the address, for example, and also because we have few time for that. But technically, we're about to have a very high level of sequenced sorting for this flow. And on the contrary, for the flat mail, we are not able today to sequence. There are several reasons for that. The first that is we have not found a technical solution which is adapted to our budget, I should say. You certainly know that on the market we have solutions for sequencing flat, and for example, with the solution from Siemens, OEMS, but this solution is too expensive for us, and it's very difficult to find a return on invest in such a solution, especially in the context of a mail decline. So we have not technical solution at a low cost, I should say, and we'll come back on that later. For the flat mail, we as we can't go at such a level, we sort part of the mail at the delivery center and other part of the mail, about 50%, at the round level, at the road delivery level. So for this reason, we have a challenge. So because the flat mail, it's about 20% of the mail, but in terms of cost for manual sorting at the delivery center level, it's about 40%. So it's a very costly process. And the challenge is so to reduce this process, reduce this cost by trying to sequence flat mail. So how do we do that? I suppose you all know the principle of sequencing, so I won't explain this principle here. You can see a case study here on the right side of the slide. Nowadays, we for example, with the standard letters machine, we have about 250 outputs, and with these 250 outputs, we're able to sequence about 50,000 of point of delivery. So this is a classic way we do that, and we are now very experimented on that process. And the specificity of the sequenced process is that we sort in several steps, and in this case in 2 steps. And the difficulty of this process is to be able, between the 2 steps, to re-inject the mail flow in the good order, in the good predefined order in the machine. So this is a way we do with the standard letter. Now, considering now the flat sorter, let's take some time to consider the characteristic of our flat sorter, which is a machine from Solistic, and we maybe you have recognized this machine. And this machine from Solistic is a machine with about 450 outputs, and with not 1 injector like a standard machine, but 4 injectors. And with this machine, we should be able, theoretically, to sequence about 50,000 of point of distribution, is the same values as for standard letter machine. But some particularity also have to be pointed. In this machine, we are not able to control the output. I mean that with this machine, there is an automatic assignation of the output by the machine, and the output is in a tray. It is not in a bin like in a standard letter machine. And the other specificity is that we have no mark for flat. We have no mark on the pieces of mail, rather than in a standard letter, we have a mark which helps us to come back to recover information from the previous steps. So how did we do that? So what is important that in our sorting center, each of these flat sorter is connected with a conveyor, which is normally used to make the output of and to empty the machine when the sort is finished, but which is also sometimes used to come back to the injector of the machine. We have a kind of a feedback loop on this conveyor, and we are able to re-inject the trays when they have been sorted 1 time. So the idea is to use this conveyor to re-inject the tray for the second step, and in making like that, we will be able to try to sequence. So it's a very schematic point of view, and in reality, we have some point to address, and I will try to list them. So the first is that as we have no mark on the machine, on the piece of mail by the machine, we are not sure that when we will read again, or when we will process again the same piece of letter in the second step, we are not sure that the machine will give exactly the same recognition, and maybe the machine will find the same street name, but not exactly the street number. So when we want to sequence, we have to get this information precisely. So this is one of the first problems we have to address. The second problem is that, or issue to address, is that when we work with a flat, we have a less important productivity by point on delivery. That is, when people receive four standard letter, standard format letter will receive maybe 1 or 0 flat. So we have a lower productivity, and this may have consequence on the fulfillment and the number of tray at the end of the second steps. And the next point is that we have, as I said before, not 1 injector on this machine, but 4. And we have also to give an order when we inject on the second step according to this 4 injector. And the last but not the least, when we will give this sequenced flat to the delivery postman, he will have to merge these flat sequences with standard sequences and also with unmechanized mail. So to try to solve this issue and to address this issue, we have worked in 2 steps. The first step was a step with low investment, so it was a kind of proof of concept, and it was conducted in the sorting center of Toulouse in the beginning of the year. And in this step, we have no adaptation of the sorter, and we have only software evolutions on the conveyor. So since we have no adaptation on the sorter, we are not able to adapt to assign statically the output of the machine. But we nevertheless we made this proof of concept, and the results were very interesting. So 3 main results for this proof of concept. The first is that we have a very good result in terms of stability of recognition. That is, when we pass the mail 2 times, the recognition is the same in the second time that in the first time. So it's very important for sequencing, of course. And this quality of recognition was confirmed by the delivery postman to who we gave this mail, and they controlled this mail, and it was a good result. The second point is, as we have anticipated, the time from reordering between the 2 steps was very long on the conveyor system, so it's a drawback that we have to solve next. And the last point was not so anticipated is that due to the low productivity of flat, we have too much number of tray at the end of the processing, and for the delivery postman, it's not tractable to have much more trays than he has before. For example, before for 1 round he have 2 trays of flat, and now he may have 4 or 5 trays of flat. So it's not tractable for him. So we are now conducting new tests and new change on the machine, because we have a next phase with a pilot pre-industrialization, and in this case we have made the change on the machine after the proof of concept. The first important change was to change the software of the sorting machine so as to be able to make static allocation of the outputs, so we can define the order in which the tray will be ejected at the end of the first steps, which is very important to reduce the time between the 2 steps. And the second that you can see on the right side of the slide is that we have made some change in the conveyor system on the feedback loop. We have installed a buffer. It's not very easy to see on the figure. We have installed a buffer so that when the tray come back for the beginning of the second step, they can be stored the time for the people who are on the convector to inject the flow. And the next important change in this phase that we are now experimenting is that we are working with real data point of delivery. That means that we have 2 steps, two ways to do that. We try to reduce the number of point of delivery to the real number of each day. For example, if we have a set of runs with 30,000 of point of delivery, in reality, each day we may have only 20% of this PDE, point of distribution, who have a mail to receive. So we try to use this data either in a real-time process, which is quite difficult to implement, either in a real-time process or in a statistical way to work. And as you can see on the figure on the right down of the slide, with about 50% of the point of delivery, we can capture 90 or 95% of the flow. So it's very important to use this because it helps to reduce the number of output necessary in the two steps, and especially in the second step. So with this new improvement, we are conducting new series of tests, and which are now in these days being conducted. And we hope that at the end of the first quarter of 22, we will have achieved this experiment, and we will be able to begin the rollout of this system. So as a conclusion, As a conclusion, I would say that we have a low-cost sequencing solution, and which is for which we have passed the main difficulty. Even we have still some difficulty to address, but the main are now passed. And we hope that we will be able to install up to 10 systems between 22 and 24. Okay. So if you have, that's for me. If you have any question, don't forget to use the Slido system or on the Teams conference. So thank you very much. So I would like now to introduce the next speaker, and the two next speakers, in fact, which are Liz Marshall and Simon Barber from Royal Mail. Liz is a principal engineering test manager, and Simon is a technical test manager, and they will present us a paper concerning improving barcode reading. So it's up to you, Lee and Simon.
Thank you very much, Bernard. Good afternoon, everybody. Just skip past the introductions there. So the challenges for Royal Mail at the moment. So Royal Mail is currently engaging in a significant transformation program where we're subtly moving from a letters business that delivers parcels to a business that actually is a parcel business that delivers letters. Currently, we've got 20 parcel machines deployed operationally, and we're now looking to deploy another 13 from 2 suppliers, which will be done over the next year or so and should complete in around 2023. Along with those additional 13 parcel sorting machines, we're also engaging in delivering 3 very large parcel sorting hubs at key locations around the UK, and the image on the right there is one such of those parcel hubs. Royal Mail is quite a diverse customer-led parcels profile, which means we accept quite a wide range of shapes of parcels in various mediums, sizes, shapes, packaging, and also printing technologies used by our customers as well, ranging from laser printers to bubble jets to very complicated thermal printing technologies. As a result of all those factors and that wide parcel profile, we obviously have quite a number of issues in around reading barcodes. And as a result, we also have now to deal with some negative operational perception of barcode read rate, because at the end of the day, they see what comes out of the machine as being rejected, not what necessarily goes into the machines. So with that challenge in front of us, I'll now hand you over to Simon, who's going to tell us all about the investigation work that we did and the analysis. Thank you, Simon.
Thank you, Lee. Good afternoon, everybody. So for the investigation, we decided we're going to try and determine barcode read rate in a live operation. So to do this, we looked to consider a number of things. Firstly, what would be the product type that we would want to try and carry out this analysis on? And we needed a product type that had a large or high volume of barcoded items. And for us in Royal Mail, we selected our Track 48 stream because this also would give us sufficient time with that product type to be able to do our physical analysis. We also then needed to try and identify suitable locations that would give us suitable volumes of this product type at times in the day that, again, would give us sufficient time to process these and analyse them. We then determined what kind of process would we follow to capture the information and then subsequently analyse this information, which is, as you can see, shown at the bottom of the slide. So firstly, we would process barcoded items only on the live mail stream using our Track 48 product type. We would carry out, we would remove, isolate the barcoded items that had been deemed to be read failures, and then we would perform a visual assessment of these items, determining whether the label was damaged, whether it was poorly printed, etc., which we'll come into a bit later. We would then scan these with a hand scanner to try and extract the barcode payload of the item, and then pass these items across a verifier as well to grade these items to ISO standards 15415 and 15416. We would then, at the end of our time slot that we would conduct this work, we would capture machine-generated data in the form of mail piece records and also images of the items that we could also further appraise later. The analysis phase then would be done offline in the office or at home, as we were working then due to COVID, and we would look to cross-match all this information using Excel, using the barcode data as the linkage to try and identify the causal factors and the root causes of the reader errors. Which brings me on to the causal factors. As you can see, we have three main causal factors that we identified that were driving poor barcode read: operational, technical, and customer. You can also see here that the not in sort plan root cause is contained within technical and customer. This is due to, from a technical perspective, the sort plan not containing the postcode in it, which is a technical issue, as technically we or the technical teams manage that. And secondly, in the customer error, because we have found, or we analysed, that incorrect postcode information was being placed in the barcode, such as it was being the sending postcode was being placed in there, not the destination postcode. Next slide, please. Thank you. So a little bit more information on the process. We decided to put together a logic flow to help us understand how we were going to tease out the issues. And the purpose of developing this logic flow was we wanted to remove as much duplication as we could from the count to try and ensure that we had a 100% cross match with all of the items that we extracted from the machine. As you can see here, we started off with misstreaming. So these are items that were not meant to be in the Track 48 product stream. Then items that weren't or were not orientated to a camera on the machine, so the camera would not have read the barcode. Not in sort plan, we've previously talked about, where the postcode contained within the barcode was not contained or it was incorrect. Machine rejects for where the machine has deemed that the item can't be processed for whatever reason. Illegal characters, so these are characters that are not contained within the C40 character set, and for us at the time, a classic example of that was a comma in the address. Payload, so the payload contained within the barcode was not correct for the barcode type, and therefore the machine was unable to process it or recognize it. The 2D barcode no read, so the machine, for whatever reason, was unable to read the 2D barcode, and again, we would appraise that. The supporting address reading system wouldn't read. Now, as much as this is not connected to barcode read, it is also provides us with additional sortation assistance. Verification, this is where the results from the verifier came into play, and this is where the barcodes were deemed to be outside of the ISO standard specs. Label, again, this is where the physical analysis came in, and where we were able to determine, based on our analysis, if there was the label was damaged in such a way that it would prevent the barcode from being read. And then finally, but not last, missort. The machine just missorted the item to the incorrect geographical location. So in terms of the percentage breakdown, I hope you can see that. Of the total items run during our numerous runs, actually, we did this on a number of sites, we found that 5.44% of the total items run on the machines were actually deemed to be no read or no barcode. And you can see there the breakdown of that 5.44% across the machines. Now, I'd like to give you some examples of the things we found in our analysis before I take you into the real figures of what that looks like. So you can see here from this slide, the extreme left image, the label has been put onto a package where the barcode is wrapped around the side or the edge of the item, which is preventing barcode read. The image in the middle, again, we have some reflective material here that is going to prevent or potentially prevent the barcode from being read. And on the extreme right, see that the print quality of that particular barcode isn't going to pass the ISO standard. And all these three reasons contributed to poor barcode read. As subsequently on the next slide, again, the presentation of the parcel on the extreme left is crumpled and creased, preventing barcode read. We have some clear zone impedance in the center, which is poor printer maintenance and leakage of ink, as you can see. And on the far right hand side, background texture is having an impact as well, causing problems. So looking at the 20 machine fleet that Lee talked about, when you take those percentage values across and put them into numbers, these numbers reflect a 12-month period, and the total volume of mail for the 12-month period we calculated to be 914 million items, of which 49.7 million of those would be classified as a no read or no barcode. And as you can see from the table there, misstreamed items and verification items and label are all the biggest hitters there in terms of what is causing a problem with our barcode read, which when you reflect that onto the 33 machine fleet, which is the future state, the numbers get significantly bigger. And again, for a 12-month period for 33 machines, we were working to a value of 1.4 billion items, of which 76.4 million would then be deemed to be no read or no barcoded items, with the same root causes being the biggest problems. So I'm now going to hand you back to Lee, who will take you through the proposed solutions that we identified through the analysis process.
Thank you. Thank you, Simon. So what did we do with all that data and analysis? Well, we're typical engineers, so naturally we wrote a report. We did a number of slides and a number of presentations, a bit like this one. But we didn't just stop there. This data then fueled the passion to start to look for resolutions, not just technically, but also through engagement with our customers, our own customer teams. So looking at some of the technical ones first, so orientation that Simon mentioned earlier, we're now starting to add additional camera systems to our parcel sorting machines to try and find those barcodes that have been previously hidden from us. The illegal character, the comma that once again Simon mentioned during his section, we're now masking those so we can then extract the payload and we can do sortation on those items as well as tracking. Some of the poor customer printing, the sawtooth example that Simon mentioned there again earlier, is a classic example of a problem with one of our customers, but they were completely unaware that that would be a significant problem for us from a sortation perspective. So we engaged with our customer teams, who have then subsequently been out and engaged with that customer, and they are now moving to newer printing technologies and different software, and also using 2D barcodes as well as the 1D barcode. The sort plan problems, we're now progressively updating our configuration systems to ensure that we encompass all those postcodes and those postcode ranges that were previously missing. We've also got a reject reduction task force now in Royal that's focusing not from an engineering perspective, but also across the operational world as well, to try and reduce those rejects and some of those other issues that are out there. Once again, we're now peeling away that layer of the onion to get to the true root cause and try and reduce that those barcode read rate problems. We're also trying to look at the potential use of other barcode reading systems. We have a third-party provider for our OCR solution, and they've got the capability, or hopefully the capability, to detect some of the barcodes that we're unable to read, so we can then find that region of interest and then focus the barcode read. And some of the errors in the barcode specification where the customer's not quite completed the payload correctly, but valuable sortation information and tracking information is contained. We're now looking at a technical solution to still extract that data, so we can still provide a sortation and tracking. So in conclusion then, data analysis has demonstrated the challenge for postal administrations to effectively and efficiently sort barcode parcels with a customer-led profile. Customers will always be the heart of our business, as well as all other postal administrations. The challenges that we face to barcode reading will always pose a significant problem for Royal Mail in our ability to meet its commitment to the universal service obligation. And our work still continues to be focused on the proposed solutions and to the root causes we've identified here in this presentation, which will enable Royal Mail to close the gap on barcode read rate. Thank you very much.
Thank you.
Thank you very much, Simon and Lee. And effectively, the value of 5% is very interesting, and it should be very profitable to compare with other operators, I suppose. And we are now turning to Luca Mathieu, who may have a kind of solution for the barcode, the difficulty of reading. Luca is a session project leader in automation, and he will present a concept of sorting on guidance. Luca, it's up to you.
Yes, thank you. My clicker is still muted, so. Okay, so I'm here to present you sorting on guidance. Like Bernard said, my name is Lucas Mathieu. I'm a senior project leader automation at bpost, and I've been fortunate enough to enter bpost 4 years ago when their biggest sorting parcel center was being opened in Brussels. And this is also where our sorting on guidance project has its focus on. So to give some context, we focus on the PSM, which is the parcel machine that can handle 24,000 parcels per hour. And it has 400 direct chutes, which we call direct chutes, the chutes where the machine directly sorts into the roll containers. It also has 140 indirect chutes, where the operator still needs to take the parcel out of the chute and sort it manually in one of 4 roll containers. And this manual process leads to errors, which we call missorts. And the missorts are a problem. About 1% of our volume is a parcel which is a missort, so it's being sent to the wrong destination. And during our investigation, we could identify 3 types of missorts. So you have the technical missorts, where the machine simply sorts the parcel into the wrong destination. Can be because of a mechanical issue, software issue, of anything which is technical. The process missorts is where the process is not being followed or not able to be followed. An example of this is where the roll cage simply gets the wrong destination label and is thus sent to the wrong destination. The manual missorts is simply where the operator puts the parcel in the wrong destination container. And on the right, you can see a bit of a breakdown. We focus on the indirect chutes, and there the manual missorts are by far the largest issue. So how can we solve missorts? Well, obviously the technical missorts is improving the machine, working with the supplier, fine-tuning the software and the mechanical parts, but also adding features. A project we're also doing is using machine vision to identify these missorts before they become missorts. The process missorts, well, yeah, you solve them by making sure your operators can follow the process and that the full process is not too complex, so you get a better quality on the process. And the manual missorts, we chose to apply technology, and this is where sorting on guidance really comes from. So what is sorting on guidance? Well, The definition is using augmented reality to assist the operator with correctly sorting a parcel, which is clear enough, but I think it's important to say that we also want to do it in a visual way with minimal impact on productivity, and that's really important. The system has two objectives. So first, obviously, we want to reduce the missorts to 0%. And the second one is, since we chose to use technology to solve the problem, we can introduce a new data point and we can confirm that the parcel has been sorted correctly into its container. So what did we do? We made two versions. So the first version of sorting on guidance was built around a smart glass. We did this 4 years ago, and the process was actually quite simple. The operator had to take a parcel and used a ring scanner to scan the parcel, which you can see on the picture on the upper right corner. The processing was done on the smart glass itself and immediately showed the destination to the operator. Operator just put the parcel in the container, and then simply by looking at the destination, he could confirm that the parcel has been sorted correctly. Additionally, since we had the smart glass being worn by the operator, we could send information to that operator. Information such as what is the best place for you to be, or is there some intervention that is needed from you, things like that. So we tested with this first version, and the results were actually quite good. We saw that during the testing there were 0 missorts, and also since we developed it with our supplier on an Android platform, we saw that it was very easy to change things, and we could move around hardware, we could add or remove hardware, and we could change things very flexibly. So that was all fine and well, but we also ran into some technical limitations, mainly around the use of the smart glass. The camera that we used to scan the barcodes is just simply not powerful enough. The device, since it does all the processing on the device itself, it got hot and it was not comfortable for the operators. And simply, it's not a device that is really meant to be used in that environment. At least it was not that way 4 years ago. So we went back to the drawing board and we said, okay, let's think about improvements. And we said, instead of having all the hardware being worn by the operator, let's integrate it into the environment of the operator. And that's where we came to the second version, where it was integrated into the environment. So practically, we just removed the smart glass and the ring scanner. We replaced the heads-up display by a destination projected on the floor. Normally, there is a picture on the right, but it's missing. That's okay. There is a video later where it's very clear how it works. The camera on the smart glass was also not available anymore because we didn't have a smart glass. So we installed a dedicated overhead projection scanner that could scan the barcodes on the fly. And the processing was also done on a dedicated machine, which is a Raspberry Pi, which is a small computer that ran the software. So we tested with this version, and we took a video to explain how the testing was done and how the setup worked. So, okay. So this is the picture. It was on the next slide. So now we can take a look at the video.
bpost is Belgium's leading postal and parcel logistics operator, and it was their automation and new equipment team that came up with the idea to use ground-projected signage as augmented reality to guide the operators. bpost granted the development and implementation of this innovative system called SmartSort to Art4L. An operator no longer needs to read a label to find out which roll cage the parcel is going to. After scanning the package, projected pictograms and text point the way to the correct roll cage. SmartSort is made from a series of video projectors strategically positioned above the work floor, and one hands-free scanner per chute. Thanks to the integration with bpost's back-end systems, SmartSort works in real time. In addition, Smart Sort also indicates when a chute is full and therefore needs the urgent attention of an operator. Smart Sort also indicates the roll cages that are ready for their next step in the workflow. Art4L also builds these smart systems with smart glasses instead of projectors. In this case, the operator wears a pair of smart glasses and sees the information projected in his glasses so he can work hands-free. With this hands-free workflow, Smart Sort ensures that your employees can work faster, stress-free, and with fewer errors.
So I hope this gave you a good example of how the system was set up, so how the hardware was installed and how it worked. But also you could see that the operator could follow the process in a very frictionless way. He could just walk into the zone. He didn't have to talk with his supervisor to get a smart glass or to start some kind of software. He could just walk in, do the work with 0 missorts and go do something else. And this is also what we saw in the results. So same as before, we saw a big reduction in the missort rate, but also with minimal impact on productivity. The second thing you should have seen in the video is when we use it to send information to the operators. So we talked about, the information that we sent was the chute being full or the next step in the process for the container. And this is really something that we try to do, is to use this platform as a way to send relevant information to the operators. So we can build upon it and try to build automations on this. But also important to note is that since we have built an integration into the bpost sorting logic backend, we can use this as a basis for other automations, such as robotic automations, where this backend integration will also be necessary. So what are the next steps for us? Well, first we want to fully implement it in the bpost Brussels site, which is the site that you just saw in the video. But also we want to transform sorting on guidance from this machine-specific setup that we built with this hardware and this environment to a generic tool that can be used not only on this machine, but also on maybe a bigger machine or smaller machines, or even just any environment, even without a machine, where an operator needs to sort something manually. So there we can just use the common core, which is the computing unit, and the integration with the backend, and we can just adapt the peripherals to the use case and the business case, because not every use case needs a state-of-the-art, on-the-fly barcode scanner or a projector installed on the ceiling. We could just as well use a simple ring scanner and some LED strips in a put-to-light system. So I hope I gave you a good explanation about what we do with sorting on guidance and how we really try to eliminate all the missorts in the manual sorting processes at bpost. Thank you.
Thank you, Luca. It was a very good explanation of how it works. So many thanks again, and we have several questions for the various presenters. I will begin by a question for Simon and Luca. There was a first question for Simon, I think. The example you presented was example of misstreaming? Or?
Yeah, the 6 images do actually show different mail types other than the track 48 that I quoted in the presentation. So the question in terms of are they? Yes, they are examples of misstreaming, but okay. I think the intention was more to just demonstrate the issues around the impact on the barcodes more than anything else. But yes, the question is correct. Okay.
And there is another question for you, Orly. What do you think is the lowest level you can get the no-read levels down? So.
Yeah, without the figures in front of me, I think, Lee, correct me if I'm wrong, if you can remember better, but I think we were able, because we did actually take the analysis down to determine what the percentage barcode read rate was and what the improvement would be if we were able to eliminate a number of these issues. And I think we were able to get, I believe, somewhere in the region of a 3 to 4% increase, Lee?
That's about right, yes. Yeah. Once we start to cut into those issues and those root causes and start to rectify them. The sawtooth barcode, as we sort of fondly named it, was a significant impact because that customer alone was posting thousands of parcels per day without understanding that or even recognizing that they were having an impact because they just saw that they'd presented a barcode to Royal Mail. So yes, around that sort of figure.
I would also say that what was interesting that came out of the analysis was the impact of the mail in each of the mail centres was different. So this particular sawtooth barcode that we saw in one site wasn't prevalent in another. So each different site had its own quirks, shall we say, in terms of large posters, shall we say, who may not be using the right standard of printing equipment, or even are aware that they're printing barcodes that just aren't going to read, and we're still having to process them manually.
Okay, many thanks for the answer. And we also have a question for Luca. Just a moment. How do you handle parcel where the barcode could not be read by the camera? It's a very close subject, but it's an interesting question.
Yeah, that's true. So the way we built the system is also to be an addition to the current system. In any case, we will keep the visual elements that were there. So in the video, it was just a piece of paper with the postal code, and the operator can always revert back simply to how it was before, reading the postal code and matching it to the right direction.
Okay, thanks. And we have also two questions concerning my presentation. And the first was, what system is being used for the dynamical and statistical sort plan adaptation? Is this being developed internally? And the answer is yes. It's internal solutions to build optimized sequenced sorting plan. We have not experimented a solution of the market, and we have developed by ourselves this solution. And the other question is more strategic. I think it's the question is, given the ongoing letter mail decline, do you see value in the process continuing in future years? So it's a very good question also, and we have made, like in any project, we have made financial studies when deciding of this project, and we have computed or calculated the return on invest, and the return on invest is about 4 years for this project. So for us, it's still including the decline of mail in the calcul, in the computation of the results. So yes, we have demonstrated that there is an interest to sort in this way. As I said at the beginning of the paper, we have not chosen to make a strong investment by buying new machine for this process. We have tried to find a low-cost solution based on the existing system we have. So this is the reason why I think the return on invest for this project was possible. So I think there is no more question. So many thanks to the presenters, and Jan, maybe you want to conclude on the session.
Thank you, Bernard, and I really appreciate the speakers for that session, and indeed all our speakers today. I'm always blown away by, first of all, the openness of your sharing. I think just the information you've disclosed and how open you are to talk about the challenges, but also how many of those challenges resonate with our own organization here at Canada Post. I mean, I think I could have been having those could have been internal presentations in many ways. So I think we've got a couple of takeaways for ourselves. I hope if you were listening in from another postal organization that you find several of those papers very pertinent to challenges you're facing and ideas. In the event website, you will be able to contact the speakers. In fact, you can contact any one of the registered participants if you're interested in reaching out to them for a follow-up. So we don't have time today to kind of do a networking part of this event, but you do have that ability through the website to make contact with the speakers or with anyone who was registered on the event. And I would encourage you to do that, because that's part of the value here, is not just stimulating the ideas and maybe seeing how others are approaching the challenges you're facing, but maybe an opportunity to follow up and have that discussion and share a bit more deeply than is possible to do in the few minutes that each paper has. I also would like to announce, very pleased to announce that we're going to be having our next event in May 2022. And this event, we believe, is finally we'll be able to get back together in person. That event will be hosted by La Poste in Paris. Details to follow. So Bernard is going to be our host for that event. But we're going to do it a little bit differently than the previous conferences that the ICPA have held. And for those of you who don't know, actually, the ICPA has been meeting for about over 40 years. And so it continues, but we're going to change the format. We find these virtual connections very helpful. So we're going to integrate a hybrid type approach where we'll have some virtual online conference papers. We're going to have a plant visit to go and see some actual operations in La Poste. And we're going to have a networking event where themes that we know are of emerging interest, we're going to actually do facilitated sessions. For example, a lot of us are working on robotics or other advanced material handling technologies. We're dealing with network design and optimization. So it's going to be a sort of three-part event: virtual papers, facility visit, and networking discussions. And so we hope that you will be able to join us in May 2022 to participate in our next event. We'll follow up on this event with a survey. We'd appreciate your feedback, and we'll be sending you communications on that Paris event in 2022. So for today, I hope you enjoyed the event we put together. I just again appreciate everybody's sharing, and please do feel free to follow up with us if we can and help you in any way. Have a great evening, have a great afternoon, and take care and stay safe. Goodbye.